This question is about ideal gases. So given a situation where we have two gases, so two separate containers connected with a pipe where we're told that it's got a negligible volume. So we've got X and Y, and we're told that after some period, then the valve W is released, so then they can mix fully. And there's no change in temperature. Now, there's a few things to bear in mind. So for any ideal gas, P1V1 over T1 equals P2V2 over T2. So that will remain constant. If the temperatures are the same, then you can actually just rule those out and say your initial pressure times your initial volume is equal to your final pressure times your final volume. And that makes sense. So if I consider each of these separately, you'll sort of see what the answer is. So we have the X container. Well, the X container, if we just consider the gas in the X container separately from the gas in the Y container, just considering the X container. So we've got an initial pressure, we've got an initial volume, and then we've got a final pressure that we don't know, and we've got a final volume. At the final volume, we add on an extra V. So it's 2V plus V, so we end up with 3V. So the final pressure, so the pressure of X due to this expansion, so due to it being allowed to occupy a larger volume, then Px, the pressure due to X, is 2/3 of the original pressure. And that makes sense. And then if we consider the same for Y, so Y is at pressure times volume, so it's 2P times V, and that's Py, and that can expand to 3 volume. So the volume is 3, so you've got the 2 plus 1, and you get the 3 again. And you'll see again that Py is 2/3 of the original volume, the original pressure P. So we've got within the 3V total volume, we've got these two pressures due to each of the gases, and the two pressures will add up. So the pressure overall will be 4/3 of P. And that's one way of looking at it, which hopefully makes sense. Another way of looking at it is just to consider the idea that we've got PV, so P2V due to X, plus then we've got P2P V due to Y. And they will equal, so those two gases in those volumes, they're the original volumes, they will mix, but they will mix in a larger volume, 3V, multiplied by this new pressure, which I'll call PF for P final. So 4PV equals 3V times PF. The V's cancel, so you end up with the final pressure is 4/3 of the original.